Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told the distance behind a marksman that an observer is standing as the marksman practices at a rifle range. We are given the speed of the bullets that leave the rifle horizontally and the air temperature on the day. We want to know the distance that each bullet will travel before the observer hears the report of the rifle. Now, we can assume that the bullet and the sound wave travel at constant speed. So we can use the equation V is equal to d over t for both. We'll take dB to be the distance covered by the bullet, and VB the speed of the bullet, d the distance of the observer, and t and v the speed of sound in air at 20 degrees Celsius. So let's first apply that equation above to the distance traveled by the bullet. So the distance traveled by the bullet before being observed by the observer, dB, is equal to the speed of the bullet, VB, times the time that the report is observed, t. Now we know the speed of the bullet, and we need to calculate the time t for the observer to hear the report. But we can apply this equation to the observer as well. So the time t that the observer hears the report is equal to the distance of the observer from the rifle divided by the speed of sound in air, v. So it can eliminate t from this equation. We'll call it equation 1. So this means that we can rewrite equation 1, dB is equal to vb times t. Eliminating the time, we can write this as the speed of the bullet, vb, multiplied by the distance of the observer, d, divided by the speed of sound in air, v. And this is vb times d over v, and all of these values are known, so we can calculate the distance that the bullet travels when the report is heard by the observer. This is the speed of the bullet, vb, which is 840 meters per second, times the distance of the observer, which is 25 meters, divided by the speed of sound in air at 20 degrees Celsius is 343 meters per second. So calculating, we get the distance that the bullet travels before the report is heard by the observer to be 61 meters.